Hello. Today we're going to do problem 994, rotting oranges. So we have this M by N grid. In this case, I'm using example 1, which is a 3 by 3. And in every cell in the grid, 0 is an empty cell, meaning there's nothing that happens there. We don't really interact with it. 1 is a fresh orange, and 2 is a rotten orange. So every minute, any fresh oranges that are 1s that are directly adjacent to a rotten orange or a 2 become rotten. And so we need to return the number of minutes that elapse until no cell has a fresh orange. And if we can't do that, we'll return -1. Say if there's an orange that's isolated and can't be reached by a rotten orange, then we would return a -1. So let's go through this problem here. So we have example 1. We just have this one rotten orange in the top left corner. And so I copy and pasted that here in the comments. Usually when I'm doing a LeetCode problem, I like to, write comments in code and then trace it out before I start writing any code. So we first have this 2 here. And we see that, if we look 4 directionally adjacent, we have these fresh oranges surrounding it. So then after 1 minute, we return these rotten. After the second minute, these 2 would become rotten. Third minute, fourth minute. And then all the oranges are rotten, so we return 4, because there were 4 minutes in between all those steps. And so the way that I like to do this is I think about how I would solve this problem if I were a human, which, I mean, I am a human, but think about, before you write out all the code, figure out, how would you solve this problem just manually, like we were just doing. So the first thing is we started with the 2s. So we started with, expanding out from this rotten orange. And then we also had to know we needed an end condition. So when are all the oranges rotten? Yeah, because at the end, when these were all 2s, we needed to recognize that and say, okay, we've met our end condition. We can return our integer, and then we're done. So return that 4. Because if you don't know when to stop, then, you can't really give a solid answer. So what I would recommend is thinking about something also important to note about this example is it only has 1 rotten orange in the top left, and same with the other example we get is 1 rotten orange and another 1 rotten orange, but there's nothing in the problem stating that it only has to be 1. So for instance, we could have this be a rotten orange here, and then minute 1, we would do 2, 2, and then also this one, 2. Second minute, 2, 2. So instead of 4, the answer in this case would be 2 minutes that elapse. So yeah, I think that, try to think of edge cases like that and not assume that just because every given example only has 1 rotten orange, assuming that we could have any organization or layout of 0s, 1s, and 2s. So now that I've gotten to this point, because, this is, you can also almost think of this like a graph problem where, we have these nodes, and the nodes are these individual cells, and they each have up to 4 neighbors or edges that they're connected to. So yeah, I would think of this problem as a graph problem and almost like a graph traversal problem. And I would encourage you every time you think about graph traversal, especially in interviews like these, it's probably going to be either DFS or a BFS solution. And that means depth first search or breadth first search. So which one do we want to use in this case? So if you think about it, so depth first search uses um, a stack, and breadth first search uses a queue. And basically, depth first search just kind of searches, in one direction, and then it goes back out. So for instance, we have this orange here. It would visit this, its neighbor here, and then visit its neighbors. Um, but if you think about, and then, it could go down here and then go all the way to the end, and then we go back out and we search this one's neighbors. Um, or, probably more likely what would happen is we would search this one's neighbors. But anyway, but if you think about the problem, what we're trying to do is search the neighbors of this one specifically. So this one in the top left corner, hopefully you can see my mouse and this makes sense. So yeah, we want to search this one's neighbors first and completely exhaust its neighbors, go here and here before we move on. So we don't want to do a depth first search. We want to search all the neighbors of a given node, then increment the minute count, and then, go from there. So in this case, we do want to do a breadth first search, which just means, like I was saying, like not searching a neighbor and then searching the neighbors of that neighbor and kind of like going down one path of the graph. We kind of want to search every level at the same time. So yeah, we want to do a BFS solution, and like I was saying, that means we want to use a queue. Yeah, the way that I kind of remember this is, I don't know why, but the way that I remember breadth first search and queue is I, for some reason, think of barbecue, like breadth first search, BQ. If that mnemonic or that device is useful, then feel free to use it. Otherwise, you can forget about it. But yes, we're going to use a queue here. And so I think now it's a good time to go into the code. So yeah, we start with the twos, and we also want to know the end condition. And so both of these require some pre-processing, because we need to know where the twos are, like know where the rotten oranges are in the grid, and we also need to know how many fresh oranges there are so that we know if we've reached like a zero condition. So we know all the oranges are rotten if we've infected or rotted, I guess I should say, all of the ones that we find in our pre-processing. So it should be pretty simple. Our pre-processing can look something like just like a nested for loop. Oops. J is less than grid 0 dot length j plus plus. So this is just a nested for loop where we can go over every cell in the grid. So we can say, okay, so we want to keep track of two things. So we want to probably have our queue. And this can be a queue of, actually, I think, yeah, int arrays equals new linked list. And so basically, what I'm thinking is every entry in this queue is just the coordinates xy of, where we want to search. You could do a similar thing. You could have two separate queues, one where it's like x's and one where it's y's, and you just pop them at the same time, and so they always kind of correlate to each other. But I think I'm going to use this approach for now. And then, let's see, we also want to have an integer of fresh oranges. And so, yeah, let's go through. So if grid I j equals 1, then we can just do fresh oranges plus plus. So we have a fresh orange. Else if grid I j equals 2, then we can take our Q and we can add, I think the syntax is something like this, ij. And so now we've, added our every rotten orange. And I think that's all we really need for pre-processing. So yeah, maybe I'll just add some comments. I like to add comments to my code just so, if this was an interview setting, for instance, they can kind of follow along with what I'm saying. And we can keep track of the algorithm that we're using. Oh, okay. And so now we want to do our BFS. So what does that look like? So we want to say, I think, while Q is not empty. So while we have basically things in the queue that we want to traverse, we can say int xy equals q, I think it's pop, and then we can say int x equals xy 0, int y equals xy 1. Okay. So now we know that these are the x and y coordinates, or the i's, the j's, whatever, the coordinates of the first rotten orange we want to explore. And I think we kind of want, I might almost put this into I think I might want to put this into a for loop, because in the case that we have multiple rotten oranges, we want to traverse them all at the same time, and then what's the word? Oh, increment that minute count. Okay, so what we want to do is we want to keep track of how many are in the queue at the start, so we can keep track of the minutes. So we can say int size equals q, I believe it's size. Yeah, and so what that does for us is we say, for instance, there are 2 rotten oranges in the corners at the beginning here. If this sets the size to 2, so that we can, traverse these, look at all the neighbors, and then we know this is a full minute because we've only kind of traversed the ones that were there first. So it spreads out equally from our, our base rotten oranges. So yeah, let's go through and we'll say for int I equals 0, I less than size I plus plus, and then let's move this logic in here. Oops. This logic here. Cool. Okay. And now we want to do the actual infection portion of things. So we'll say, maybe I've been watching The Last of Us too much, using the word infection, but okay. If x is less than, or I should say x plus 1 is less than grid dot length, then we can check if grid x plus 1 y is equal to 1, then we know that this is a fresh orange that's adjacent directionally to a rotten orange. So we want to say q, I think it's add, push maybe? I don't know. New int x plus 1. Oh, sorry. X plus 1 y. Cool. And then we want to do this for pretty much every neighbor. This isn't like the cleanest way to do it, but this is definitely a way to do it. So yeah, we can say x minus 1 is, oh, this should be less than. This should be greater than equal to 0. And I hope this makes sense. We just want to make sure we don't go out of bounds, because if we go out of bounds, then we're going to get an exception that, we're trying to access a place in memory that's out of bounds, so we won't be able to obviously get a valid cell from the grid. So let's do -1, and then we want to do the same thing, q add -1. Now y, we want to make sure that that is less than 0 dot length. We'll do y plus 1, and this kind of pattern comes up a lot. So good to, I think there's kind of a more intelligent way to do it, where you can create a direction or a array list of different directions. But for me, this works just fine. Greater than equal to 0, y minus 1, and y minus 1. And then every time we do this, we have this fresh oranges count. And so we want to, this is like us basically infecting that. So let's add the infection grid x plus 1 y. We can set that equal to 2. Oops, incorrect syntax there. Whoa, weird copy and paste behavior. And we go here. Cool. And then let's say x minus 1. This will say y plus 1. This will say y minus 1. And then we'll also want to reduce that fresh oranges count. So fresh oranges minus minus. Fresh oranges minus minus. Or like decrementing. One more. Fresh oranges minus minus. And at the end of all of this, we've gone through the whole for loop, let's actually create an integer for minutes equals 0. Because like I was saying, after this we want to increment our minutes so that we get our answer. And then after all of this, what we want to do is we want to return, so basically return fresh oranges equals 0. If it equals 0, that means we've hit our end condition that we talked about. So if it does equal 0, we just return minutes. Otherwise, we return -1. So yeah, I think we'll see if the syntax holds up. But let me run this real quick. Okay, it does not hold up. So we don't queue, or we don't pop from the queue. What do we do? Queue, poll? I think it's poll. Let's see what that does for us. Okay, we get a wrong answer. Let's see. -1 is right. So we're getting an answer that's 1 plus, because at the very end, when the queue is empty, so basically we've gone through, like when we get to minute 4, for instance, we still execute the while loop one last time. And so we don't want that, so we have to do minutes -1, because we're incrementing this at the end, but we're doing an extra iteration, because we're adding this last orange and then going through the loop again. So if we do that, return it, and then we can submit. Let's see. Grid is 0. Oh, interesting. So this is a case where, we have this 0 here. There are no fresh oranges. Interesting. So I think we just need to add a case here. If fresh oranges equals 0, then we've kind of done our job. So we can return 0. Because what's happening is this fresh oranges is 0. We go through the loop. The queue is empty, so we never increment minutes, and then we do minutes minus 1 because we're trying to take care of that extra iteration case. So fresh oranges does equal 0. We do return the minutes minus 1, but since nothing happens, 0 minus 1 is -1, which is not what we want. So by trying to catch this extra iteration case, we also need to catch this edge case. So let's submit this now. Cool. Yeah, so we can see runtime is good, complexity 1 millisecond, and memory is good too. So yeah, I hope this was useful, and I'll keep making videos. I also, offer mock interviews through ADP List, so I'll put a link down there as well if anyone wants to do a mock interview, like in person with me. But yeah, thank you so much for tuning in, and I will see you guys around.